Okay, hi James. So this is a better explanation of why the moon appears to move from the eastern sky to the western sky throughout the night, or throughout the day, if it's visible in the day. Um, but but why the eclipse shadow, the umbral shadow, moves from west to east during the course of the eclipse in relation to a fixed point on the rotating Earth. So what are we looking at here? We have got the Earth down here. We have the moon up here, and the moon's shadow coming down this way. The sun's rays are coming down pretty much parallel, and so that moon's shadow is going to be in that kind of position, or as the moon moves in its orbit across between the Earth and the Sun. We have an observer down at the bottom here, which is the little red dot on the right hand side of the Earth, and you'll see this blue arrow pointing this way. This is the observer's zenith. So for that observer standing on the Earth, and by the way, just to explain the Earth, we're looking at it top down. There isn't really a top to the Earth, but we're looking at as if we're looking down on the North Pole. So it's going to be rotating in this direction from west to east. So for this observer, the little red dot there, they're just on the terminator line, transitioning from night into day. If they look directly east this way, they see the sun rising just over the horizon. The blue arrow shows their zenith, and anything to this side of that blue line is their eastern sky. Anything to this side of that blue line is their western sky. So their zenith is what delineates the difference between the eastern sky and the western sky. Okay, so next step, we're going to rotate the Earth. And by the way, sorry, this orange line here is the line from the observer to the moon. So that shows which way the observer is looking if they were to look and see the moon. So you can see at the moment, this is in the early morning, the moon is in that observer's eastern sky. It's in the east, okay? Not too far from where the sun would be located. So we're going to move 1 hour later. 1 hour later, the Earth rotates by 15 degrees. That's 15 degrees rotation. And at the same time, the moon moves by about its own diameter in the sky, within its orbit. The moon's just over 2,000 miles in diameter. It moves about, and it orbits at around 2,200 miles an hour. So every hour it's going to move one diameter, more or less. This, by the way, is not perfectly to scale. I'll show you in a minute why it's not to scale with distance. The scale is approximately correct as far as the sizes of the Earth and the Moon go. The rotation is 15 degrees per hour. Each step is 15 degrees, and the motion of the Moon is approximately correct, but the distance is, the Moon's a lot closer than it should be, or it would be in reality. Okay, so we can see the Earth rotated, and as it rotates, and this I think is where the issue that you're having was, the observer's zenith also rotates. So now that zenith is not pointing in the same direction anymore. The east and the western sky is different for that observer, and it changes minute by minute. It's just that you're fixed. When you're fixed on the Earth, as far as you're concerned, east is always east, west is always west, but that's relative to your position on Earth. So 1 hour later, the Earth rotates, and the Moon moves in its orbit, which is also, as we've said, in its orbit, orbits the same direction as the Earth is rotating. So we keep going 1 hour later, and you'll see as the Earth is rotating and the Moon is moving, then that blue arrow, which denotes the zenith of the observer, the line between east and west, gets closer and closer to the orange line, which shows the direction to the Moon. So it's getting higher and higher in the observer's sky, and getting closer to the centre of the sky, if you like, the delineation between east and west. So hour by hour, we move along. Now the eclipse shadow is on the Earth. So at this point, the eclipse shadow is about hitting the Earth at about the point of our observer. Now look what happens when we go one step further, 1 hour further. that eclipse shadow moves to the east of the observer. So that eclipse shadow, let's just run that again, about to hit the Earth. It's on the Earth around at that red dot, and then it's further east than the red dot, and the next hour it's further east still. So that eclipse shadow has moved from west to east during those 3-4 hours or so. At the same time, look at where the blue line is now, the blue arrow, how close that is to the orange line that goes to the moon. And here, next hour, it crosses over. So now that moon, for the observer, has transitioned from the eastern sky into the western sky. And hour by hour, it will get lower and lower in the western sky, until eventually that observer will transition back into night with the moon and the sun, in this case, low in the sky. Now, of course, this is a new moon, the sun's behind it, so you're not going to actually see the moon, but the same rationale applies. Whether you're on the day or the night side of the Earth, if the moon is visible, then this is what happens. So let's just run that again. I'm going to run it a couple more times. Just first of all, just concentrate on the position of the moon, whether it's in the east or west of the observer. So it's in the east, gets higher in the sky, higher in the sky, higher in the sky, until it crosses over here between the eastern sky and the western sky. Now concentrate on where the moon shadow is. The moon shadow is passing across the Earth in relation to that fixed point, the observer, the red dot. It starts in their west, and it moves further to their east. So that's the reason, James, that this works. Now, I said that this wasn't to scale with distance, and I'll show you why, because if it was to scale with distance, then that would be the graphic you'd see on the screen. You wouldn't see any detail. It'd be difficult to demonstrate this. But if you want to draw this out yourself to scale, do it yourself. Go ahead and do it. You'll get exactly the same results. Okay, so hopefully that explains things. And yeah, let me know if you have any questions. Okay, take care.